We are learning about the segment addition postulate today. Segment addition postulate applies when you have three collinear points along the same line. So in this figure I have point B, it is between points A and C, and I have two smaller segments that comprise a larger segment, AC. The segment addition postulate states that if you have point B between points A and C, then the entire length of segment AC is equal to segment lengths AB and BC. And the important thing to remember is in blue here, in order for this to work, you have to make sure that your 3 points are collinear. The segment addition postulate does not apply to non-collinear points. Let's take a look at some examples that use numbers to help us sort of figure out what's going on. In example 1a, I'm asking you to find PR. Now, according to segment addition postulate, which is here at the top, if I have a point that is between two others, then I can add up my two smaller segments to equal the larger. Q is between points P and R. So if I'm going to write this out in postulate form, I would write out the length of the longer segment, which is PR. That is equal to my small segment PQ plus QR. And now all I'm doing is filling in the blanks. So I look here, PR is what I'm looking for. That is not given. I'll call this X. PQ has a length of 7, and QR has a length of 9. So just following this, solving the equation, X is going to equal 16. And since X is what represents PR, PR is equal to 16. Notice I'm not using the segment line above our PR. That's just talking about the segment itself, so I don't want to use that. When I'm talking about specific measurement, I'm going to leave that off, so we're just going to write the letters PR here. Okay, example 1b, I have segment JL, I'm missing segment JK, and that's what I'm looking for. So I'm going to fill in my postulate just like I did up here. So I have JL is equal to JK plus KL. And we're filling in. JL has a length of 23. JK is missing, so that's our X. And KL is 6. Okay, so now we're going to subtract 6 on both sides. So that would mean that I have 17 equals X. And since X represents JK, that means that JK is 17. Alright, example 2. Same process, only this time I'm asking you guys to find a variable. I'm giving you all three values and we're going to write an equation for it. Okay, so this small segment has a length of z minus 3. So I'm going to use this as a value, z minus 3. And I have a length of a smaller segment that is z plus 4. So we'll use this as well. And the entire segment length is 4z minus 15. So I'll have this at the front of our problem here. And according to the segment addition postulate, the longest segment's length is equal to the sum of the two smaller segments. So I've set up an equation and now we're going to be solving for the variable z. So on the right side, my common terms are z plus z. I have 2z. Negative 3 plus 4 is positive 1. The left side remains the same. And now we're isolating z. So this is just an algebra problem, a multi-step problem. Add 15 on both sides. This will be 16. I'm going to subtract 2z on both sides. And I'll have 2z is equal to 16. Divide both sides by 2. And z is 8. Alright, last thing we need to talk about are congruent segments. Congruent segments are segments whose measures are equal. So in this diagram I have segment length DE and EF, and they both have a red line through them. These red lines denote congruency. So if I said that DE was 6, that would mean that EF would be 6 also, because their measures are going to be equal. And if I want to write that DE is congruent to DF, I would say that segment DE is congruent to segment EF, and that's how we would write this out using their names. If I'm talking about their measures, then I would say that DE is equal to EF. So non-measure usage, we're using the congruency sign, and measuring specifically, we would use the equal sign. Alright, let's take a look at example 3 here. We're just deciding whether line AB is congruent to line CD. So if AB is congruent to CD, that means that their measures are equal. AB is broken up into 2 segments. One has a measure of 3 and the other is 9. So according to our addition postulate, AB would be equal to 3 plus 9. So AB is equal to 12. CD is done the same way. CD is broken up into 2 segments, and so I have CD is equal to 6 plus 7, that is 13. 12 is not the same thing as 13, so that means that their measures are not the same, which means that they are not congruent. So for my answer, I would write not congruent. That concludes our segment addition postulate video, and we'll see you in class.